Hi everybody. Boy, this is 2 chapters left. Can you imagine? It's gone so fast for me anyway. Hang in there. You've only got a couple things left, and then we're done with the course. So you should be proud of yourselves for sticking to it. This online learning is not easy. So I hope that the lectures have made things easier for you, and that you've learned enough so that you can continue on with your new classes. All right, so chapter 10 only has 4 sections that we're going to cover. Now, obviously, it has more. It has a lot more, actually. But we're just going to cover 4 of those sections. And it's all about quadratics. Okay, now quadratic, come on. Quadratics in their standard form look like this. Okay, that's your standard form. Now before, what we were doing with those things is we were factoring and doing all kinds of stuff with them, and we were, solving for x. And we're going to continue to do that, but not everything can be solved through factoring. Okay? There was, if we have x squared plus 5x plus 6 equals 0, well, that's pretty easily factored, right? That was x plus 2x plus 3. But what if I changed this to a 6? Now what? Well, now it's not factorable anymore because nothing multiplies to 6 and adds to 6 at the same time. So this doesn't work anymore. So we're going to find new ways of solving. One is going to be called the square root property, which we'll do in this section. Then we're going to complete the square. Then we're going to use the quadratic formula. Okay? So these quadratics need to be solved, and anytime that we have a quadratic let's just draw a picture right here. Typically we have 2 solutions. The solutions are the x-intercepts. Okay, and these are also called the zeros of the function. Okay, these are the zeros. Why is that? Well, look at what we have here. We have this side is equal to 0. Remember, our function usually looks like this. If we put it in function notation, and f of x is always y. Okay? So if y is equal to 0, see how I'm transforming this? If y is equal to 0, it's only 0 at these 2 spots. Everywhere else it has a coordinate other than 0. I'm too low here. Okay? So that's why they're called the zeros of the function. Is they're the same thing as trying to find what x is or trying to find the x-intercepts. They're all the same thing. So we've learned a ton about radicals. So we're going to continue on with our knowledge of radicals. And let's start with this first one here. The square root property says that if I take the square root of this side, it's going to wipe this square out, because remember, the square root of a square is itself. So what I'm trying to do is I'm trying to solve for x. So I have to square root on both sides. Whatever I do to the left side, I have to do to the right side. So the square root of a square is x. And let's see about the square root of 196. I'm thinking that might be a perfect square. It's 14. Okay. Now, how do I get these 2 solutions? Okay, I'm going to be getting up to 2 solutions. Well, when we just evaluated the square root of 196 before, we said that was 14. But when we solve using that, then we have to use the positive and negative values of that, because a negative 14 squared is also 196. And same with 14 squared. So that's how we get the 2 answers here, is we do the positive and negative values of these. So here you'll do 14 comma negative 14, because both of those would work in that equation and when you plug them back in. This is telling us that we need up to 2 solutions. Okay? What about something like this? t squared equals 17. Well, again, I've got a square, so I'll square root both sides. The square root of a square is itself. And what about this thing? Well, 17 is prime. So we're finished. You have to go back into your radical rules. Do you have a perfect square underneath that radical? No, because 17 is prime. So I'm finished there. So I'm going to put a 17, get out from underneath there, and a negative. Don't put the 17, or don't put the negative underneath there. Make sure it goes out front. Okay? Now, obviously, these aren't going to be this easy. You know, like this one. M squared equals 75. Again, I'm going to square root both sides. So I have m equals plus or minus the square root of 75. Now I've got to go back into my list of perfect squares to see what's in there. So let's make a list of our perfect squares. One more time. You should have these handy somewhere. If you don't, just make them up. 6, 7, 8, 9, 10, ... Okay, so we're trying to find what's inside of 75, and it's going to be at 25, correct? That's the biggest perfect square that sits within that. So here we're going to say we have 25 times 3, which is equal to 25 times 3, using our product rule, which is equal to 5 roots of 3. Now, just like before, we can check for equivalency at this point. So you would want to check to see what the decimal equivalency of the square root of 75 is, and then we'll just take the positive value here and then do 5 square roots of 3 and see if it works out to be exactly the same. So at least you know you've reduced it down correctly to this point. And there's nothing left in a 3. Okay? So here you would do 5 square roots of 3, comma, negative 5 square roots of 3. All right? Okay, so what did you notice about these 3? You notice that the variable was isolated in all of these, and we went ahead and did all the square rooting right off the bat. Take a look at this one. It's not. So now what do we do? Well, now we make the variable isolated. So that's our first step. We force it to be on its own. So we will add 33 across, right? So we have 3x squared equals 33. And then we will divide by 3. So we have x squared equals 11. Proceed from there. 11's prime. That's like the 17. So that one's really easy. Okay, so that's basically, what you'd want to do. Now here we have the square is isolated, which is what we want. Okay, so let's do this one. We have, okay, the square is isolated, so we can go ahead and square root right off the bat. The square root of a square is itself. Square root of 25 is either positive or negative 5, and then we would subtract the 1. So we have x is equal to plus or minus 5 minus 1. Now here's where we split. Use the positive value, 5 minus 1 for 4. Or use the negative value, negative 5 minus 1 is negative 6. So these are your two solutions here. Okay. Let's take a quick peek at what the calculator is going to tell us with this kind of stuff. Let's enter in this function here. Now remember, this is a y equals, so we have to have everything set to 0 when we do this. So when I put this in my calculator, I'm going to put in minus 25. Okay, because if I subtracted my 25 across, then it would be a negative 25 on that side. So let's take a peek at what's going on in here. So we have x plus 1 squared minus 25. Okay, so there's my function. And I'm saying it's crossing at 4 and negative 6, because remember, those are my solutions or my x-intercepts. And is it? 1, 2, 3, 4. There's one. 1, 2, 3, 4, 5, 6. There's the other one. Okay? We can verify that precisely through the table. Here's 4, 0. That one works. And then we'll go to -6. There's the other one, -6, 0. So if these are my zeros where y is equal to 0, then the calculator can help me find, not help me find them, because on some of these it can't. I'm going to show you how to do it with radicals though, tracing and all that stuff. But when they're nice whole numbers like this, you can really see it on the graph. Okay? And you'll do the same thing here. Let's try this one. This one's not so nice and neat, I do believe. It's going to be a mess. Okay, so we have that. Okay? Square root of a square is itself. 98. Okay, so now we're going to have to start hunting around what's in a 98. Okay, I'm looking for numbers like this. So I want to see what we've got in there. Do we have a 49? Let's just see here. So 98 divided by 49 is 2. So yes, we do have that. So let's start there. So we have x plus 7 is equal to plus or minus 49 times 2. And then we can split that. Okay, I'm going to go up here next. So maybe some of this space over here. So now I have x plus 7 is equal to plus or minus 7 roots of 2. Square root of 49 is 7. I've got to retain this plus minus because that's where my two solutions are coming from. And now I'm going to subtract my 7 across. So I have plus or minus 7 root 2 minus 7. Okay? This is something I can't check in the calculator the way it's sitting. So I'm going to get my decimal equivalencies on these first of all, and then I'll show you how to check them on there. So the first one, we're going to use the positive value of 7. So we have 7 square roots of 2 minus 7. Okay, we need a decimal equivalency on these. So we've got 2.899495. And then we'll do the negative 7 roots of 2 minus 7. And we get a negative 16.899495. Okay? So these are my decimal equivalencies of my two solutions that I want to check. Next, I'm going to go into my y equals, and I'm going to put in this value with the 98 subtracted across. Okay, remember it has to be set to 0, which on these are pretty easy. All you have to do is just take that one little piece across. Minus 98. All right. All right, so now we're expecting it to cross over at negative 16, and this only goes to negative 10. So the first thing that we'll do is we'll change our window setting so that we can see it. That's my x minimum value. I want to go past negative 10. I want to go to, let's say, negative 20. Everything else seems to be fine. So we're just going to scooch it over a bit. And we've got these two values here. Now I'm not going to find those in the table because these decimals don't end. But I can trace them out and find them through the calculation button here. Okay? So I'm going to calculate. Before we were doing mins and maxes for the vertex, but now we're going to do a 0. All right? It knows what a 0 is. So first of all, I have to find my spider. Where is he? Sometimes it's hard to find these little, it's on the graph somewhere. Maybe I gotta go the other way. See, sometimes you gotta just click on this until he appears. And I don't see him. Okay, I gotta go this way, I think. Let me find you, spider! Do you guys have this trouble too? I don't have it as much on my handheld calculator. It's more on There he is. It's more on my simulator that I have this trouble with it. All right, so the left bound on this one would be above. Whoops. All right, so I want to go above on my left, enter, below on my right, and hit enter. So we've got negative 16.89949. Wow, 89949. Look at how accurate that is. So that one looks really good. And then I want to do it again. I want to calculate my other zero out. Now I'm here, so I got to go all the way over to here. So now I got to keep clicking this until I see it on the right side. At least I know I'm going on the right way. And I'm going the right way this time. I know that for a fact. So we'll just keep clicking this until he appears. That parabola must go way, way down there. Whoop, there he is. Okay, so the left side is below. The right side is above. And look at that, 2.88949. 5. So I have these spot on. Now my math lab's not going to want these answers, it's going to want these answers. Okay, so that's why you can use the calculator to check your answers, but you can't change this into that. At least I don't know how. If you know how, please let me know. But I don't know how to change that into that. But anyway, so you're going to put in, oh, I suppose we should just do it. Okay, so 7 roots of 2 minus 7, comma, negative 7 roots of 2 minus 7. Okay? So you want to separate them out with your plus and minus. If you were in a classroom with me taking a test on paper, I would take the plus minus. I would. This is a perfectly acceptable answer, but my math lab can't do that. So, okay, so you can always find your solutions, whether they're nice whole numbers like these. You can just find them through the table, or you can get decimal equivalencies and you can calculate them out and actually, you know, trace on the parabola and find them exactly. Now, during a test situation, if you do your decimal equivalencies and this thing's telling you something different and you double check to make sure you put your function in there correctly, then you got to go back and fix something because something's off. Okay? I'll leave that one for you to do. All right. What about something like this? What do we do with something like this? The square root of x squared is negative 49. Well, I'm going to, first of all, just show you something in the calculator. So it's negative 49. So I'm going to add my 49 across. So I have this for my function to put in there. I want to see what's going on. First of all, I'm going to zoom 6, get my standard 10 by 10 back. Okay. I want to change my function into my new one. So I've got x squared plus 49. Okay. Take a peek at what it's looking like. Well, I don't see it at all. So let's do zoom 0. Okay. This is not the x-axis here. It's way, way up there. Look at my window setting. I'm up in the 149 and my y minimum is at 50. Okay, so this thing is hanging way up in the air. This is, it's way, way up there like this. Okay, I can see that for my y minimum is down at 50. And that's where my graph is. Okay, so what about something like this? Well, this is telling me that I have complex solutions because there are no crossings on the x-axis. I still have solutions. I can still find them through the square root property. Okay, I can't check them on the calculator. All I can check is that, yes, indeed, they are complex, but I can't ever find them through the calculator. So if I have my original x squared equals negative 49, and I take the square root of both sides, then I have x is equal to plus or minus the square root of negative 49. And we know that the square root of negative 49 is 7i. So that's my answer. Can I check that on here in any way, shape, or form? No, I can't. So when we have complex, check to make sure that your graph is not crossing, first of all, to make sure that they are complex, and then just double check your work. Okay? You can also plug this back into the original. So here, let's do that. We can always do that. But when these get really ugly, then we probably wouldn't want to. So let's check the 7i. If we had 7i squared equals negative 49, is that a true statement? Well, we're saying that it is. So let me lift this up just a little bit. All right, so this would be 49i squared is equal to negative 49, right? 7 squared, I squared. Remember what I squared is. I squared is equal to negative 1, so this indeed is negative 49. So negative 49 is equal to negative 49. Okay? So it does work, but we're not able to use the calculator as much as we have been with complex solutions. Okay? And then you're going to be doing the same thing on all of these. You're going to be, simplifying your radicals and all that stuff. Maybe we'll just do one more. Should we just do one more? Can't hear you. All right. Well, then I will choose to do one more. All right, so let's say we have 2k minus 1 squared equals negative 8. Is my square isolated? Yep, it sure is. So I can start off by square rooting right off the bat. So my square root of a square is itself. So we have 2k minus 1 is equal to the square root of negative 8, and I want the positive and negative values of that. All right. This has a perfect square of a 4 in there, so I can start breaking that apart. I've got 4 times 2 times negative 1, right? It's also got the negative 1 in there that I have to pull out. So I have 2k minus 1 is plus or minus. This is a 2 and an I. 2i roots of 2. So I've simplified my square root of negative 8 first of all. Now I've got to isolate my k. So I will add a 1 across to both sides. This is gone. So now I have, I'm going to go up here, 2k equals 1 plus or minus 2i roots of 2. Doesn't matter if I put 1 plus or this plus 1. And then I'm going to divide through by 2. All right. So I have k is equal to 1 plus or minus 2i roots of 2 over 2. Now, my solution better be in a plus bi form, which this is not quite yet. Okay, so remember that's how we have to abide by all of our radical rules, and we have to abide by all of our complex rules when we write our solutions. So I will split this and divide each piece by 2, and then I will cancel my 2's here. And now am I done? Pretty sure I do. I have an a of half and I have a b of square root of 2. So this is the final form it's going to want it in, at least I think it is. All right, so let's get that bad boy in there, huh? Okay, so I have 1/2 plus I roots of 2. Now why don't I have an I on my, I don't know. If you don't see it, you can always go in here and use the I that way. Okay? But usually it gives you what you need on here. So that's kind of weird. Minus. I'm just using my keypad. I roots of 2. Good job. Okay? So the first section of chapter 10 is using the square root property to solve. So far what we've got is factoring, and now we have the square root property. So we have 2 different methods of solving quadratics. The next 2 sections will be two new pieces we're going to do completing the square, and we're going to do the quadratic formula. And that's all I have up my sleeve. So, okay, so you know how to check it with a calculator. You know how to do these things by hand. I think you're good to go. So I will see you for section 10.2.